It appears that the electrical panel has been wired improperly. A single-phase 120/240 volts electrical panel usually includes two hot wires that measure 120 volts to neutral, along with the neutral wire. These two hot wires should be connected to opposing sides of the panel, with the neutral wire connected to the panel's center. The current configuration where two hot wires are on one side and one hot wire is on the other side is incorrect and could pose a safety hazard. It is recommended to disconnect the wires and reconnect them properly. These are the steps to correctly connect the wires. Firstly, turn off the power to the panel at the main breaker for safety. Secondly, disconnect all the wires from the panel to start fresh. Thirdly, connect one hot wire to one side of the panel and the other hot wire to the opposite side, ensuring they are balanced. Fourthly, connect the neutral wire to the designated neutral busbar located at the center of the panel. Fifthly, after confirming all connections, carefully turn on the power to the panel at the main breaker. After the wires are correctly connected, use a voltmeter to test the voltage at each outlet, making sure they receive the appropriate voltage. The correct voltage readings should be 120 volts from each hot wire to neutral and 240 volts between the two hot wires. Improper wiring can lead to several issues, including electrical shock, fire hazards, and damage to appliances. Ensuring the wires are properly connected is crucial for maintaining a safe electrical system. If there is uncertainty about any part of the wiring process, it is always best to consult with a qualified electrician. Correctly wiring a 120/240 volt single-phase panel involves several key concepts. Understanding these concepts is important for ensuring safety and proper functionality. The panel receives power from the utility company through two hot wires and a neutral wire. The two hot wires carry alternating current or AC voltage. In a 120/240 volt system, each hot wire provides 120 volts to neutral, and the voltage between the two hot wires is 240 volts. The neutral wire provides a return path for the current and is typically grounded at the service entrance. Inside the panel, circuit breakers protect individual circuits from overcurrents. Each circuit breaker is rated for a specific amperage, such as 15 amps or 20 amps. Connecting too many devices to a single circuit can cause the circuit breaker to trip, cutting off power to the circuit. The panel also includes a ground bus bar, which is connected to the grounding electrode system. The grounding electrode system provides a path for fault current to flow back to the source, helping to protect against electrical shock. When connecting wires to the panel, it is important to follow all applicable electrical codes and safety regulations. This includes using the correct wire size for each circuit and making sure all connections are tight and secure. Also, double-check the voltage and amperage ratings of all devices and appliances before connecting them to the panel. Remember, the two hot wires should be placed on opposite phases. The reason for this is to balance the load in the electrical system. The two hot wires coming into the panel are 180 degrees out of phase with each other. That means that when one hot wire is at its peak voltage, the other hot wire is at its minimum voltage. By connecting circuits to both hot wires, the load is distributed more evenly across the two phases. If all the circuits were connected to the same hot wire, it could cause an imbalance in the electrical system. This imbalance could lead to voltage fluctuations and other problems. The neutral wire plays a critical role in a 120/240 volt single-phase electrical system. It provides a return path for the current to flow back to the source. Without a neutral wire, the circuit would not be complete and the devices would not work. The neutral wire is typically grounded at the service entrance, which provides a path for fault current to flow back to the source. This helps to protect against electrical shock. The neutral wire must be properly sized for the circuit it serves. If the neutral wire is too small, it can overheat and cause a fire. The size of the neutral wire is determined by the amperage of the circuit. The National Electrical Code, or NEC, provides guidelines for the proper sizing of neutral wires. The ground wire is also an important safety feature in an electrical system. It provides a path for fault current to flow back to the source in the event of a short circuit or other electrical fault. This helps to protect against electrical shock. The ground wire is typically connected to the metal chassis of appliances and other electrical equipment. This ensures that if there is a fault, the current will flow back to the source through the ground wire rather than through a person who touches the equipment. The ground wire must be properly sized for the circuit it serves. If the ground wire is too small, it may not be able to carry enough current to trip the circuit breaker in the event of a fault. The size of the ground wire is determined by the amperage of the circuit. The NEC provides guidelines for the proper sizing of ground wires. When working with electrical panels, it is important to take the necessary safety precautions. Always turn off the power to the panel before working on it. Use insulated tools to avoid electrical shock. Wear safety glasses to protect your eyes from flying debris. And if you are not comfortable working with electricity, hire a qualified electrician. Remember to consider the load calculation. Before adding any new circuits to an electrical panel, it is essential to perform a load calculation to make sure that the panel can handle the additional load. A load calculation is a process of adding up the total amperage of all the circuits in the panel. The total amperage should not exceed the ampacity of the panel. The ampacity of the panel is the maximum amount of current that the panel can safely handle. The ampacity of the panel is typically marked on the panel's nameplate. To perform a load calculation, one needs to add up the amperage of all the circuits in the panel. The amperage of each circuit can be found on the circuit breaker. For example, a 15 amp circuit breaker can handle a maximum of 15 amps of current. A 20 amp circuit breaker can handle a maximum of 20 amps of current. Once the amperage of all the circuits is added, compare the total amperage to the ampacity of the panel. If the total amperage exceeds the ampacity of the panel, then some circuits will need to be removed or upgraded to a higher ampacity panel. Another crucial aspect of electrical panels is grounding and bonding. Grounding is the process of connecting the electrical system to the earth. This provides a path for fault current to flow back to the source in the event of a short circuit or other electrical fault. Bonding is the process of connecting all the metal parts of the electrical system together. This includes the metal enclosures of appliances, the metal conduit that carries the wires, and the metal ground rods that are driven into the earth. Bonding ensures that all the metal parts of the electrical system are at the same electrical potential. This helps to prevent electrical shock. Grounding and bonding are essential for safety. They help to protect against electrical shock and fire. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements must be followed to ensure safety. When installing a new electrical panel, it is important to follow all applicable codes and regulations. The NEC is the most widely used electrical code in the United States. The NEC is updated every 3 years. It is important to use the latest version of the NEC. State and local codes may also apply. These codes may be more restrictive than the NEC. It is important to check with the local building department to determine which codes apply. Permits may be required for electrical work. A permit is a document that authorizes electrical work to be performed. Permits are typically required for new installations, alterations, and repairs. The local building department can provide information about permit requirements. Inspections may be required after electrical work is completed. An inspection is a process of verifying that the electrical work was performed in accordance with the applicable codes and regulations. The local building department can provide information about inspection requirements. Another important factor is wire sizing and ampacity. The size of the wire used for each circuit must be appropriate for the amperage of the circuit. If the wire is too small, it can overheat and cause a fire. The ampacity of a wire is the maximum amount of current that the wire can safely carry. The ampacity of a wire is determined by the size of the wire, the type of insulation, and the temperature rating of the wire. The NEC provides tables that list the ampacity of different types of wires. These tables must be consulted to determine the proper wire size for each circuit. The NEC Table 310.15 is an example of this. Circuit breakers are designed to protect circuits from overcurrents. When the current in a circuit exceeds the rating of the circuit breaker will trip. interrupting the flow of current. Circuit breakers are rated in amps. The amperage rating of a circuit breaker is the maximum amount of current that the circuit breaker can safely handle. Circuit breakers are also rated in volts. The voltage rating of a circuit breaker is the maximum voltage that the circuit breaker can safely interrupt. Circuit breakers should be properly sized for the circuits they protect. If a circuit breaker is too small, it will trip too often. If a circuit breaker is too large, it will not protect the circuit from overcurrents. Arc fault circuit interrupters, or rough size, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. Size are required in many areas of the home, such as bedrooms and living rooms. Brown fault circuit interrupters, or GFCIs, are another type of circuit breaker that is designed to protect against electrical shock. GFCIs are required in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Surge protectors are devices that protect electronic equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage electronic equipment. Surge protectors are typically installed at the electrical panel. They can also be installed at individual outlets. When selecting an electrical panel, it is important to consider the size of the panel. The size of the panel is determined by the number of circuits that are needed. The panel should have enough space for all the circuits that are needed, with some extra space for future expansion. The panel should also be rated for the proper voltage and amperage. Electrical panels are available in different voltage and amperage ratings. It is important to select a panel that is rated for the voltage and amperage of the electrical service. Electrical panels should be installed in a dry, well-ventilated location. The panel should be accessible for maintenance and repairs. The panel should not be installed in a location where it is exposed to moisture or extreme temperatures. When working with electrical panels, it is important to follow all safety precautions. Always turn off the power to the panel before working on it. Wear safety glasses and gloves. Use insulated tools. And if you are not comfortable working with electricity, hire a qualified electrician. Remember to use the correct wiring methods. There are several different wiring methods that can be used for electrical wiring. The most common wiring methods are non-metallic sheath cable, or NM cable, and metallic conduit. NM cable is a flexible cable that is used for residential wiring. Metallic conduit is a rigid metal tube that is used for commercial and industrial wiring. The wiring method that is used will depend on the application. NM cable is typically less expensive than metallic conduit. However, metallic conduit provides better protection against physical damage. When installing electrical wiring, it is important to follow all applicable codes and regulations. The NEC provides detailed requirements for electrical wiring. These requirements must be followed to ensure safety.